Okay, so there's four more problems in this video that are on the second slide. So you don't see them in this moment, but they're there. Now, first one, 59, negative 5.6 plus 7.4. There is a commutative property idea here. Okay, we can change the order of these. I'm going to do it just to illustrate something. Okay, we could write it as 7.4 plus negative 5.6. Okay, and there's a rule for adding positive and negative numbers. But I just want to show you this. You can turn this from 7.4 plus negative 5.6 to 7.4 minus. We can change the sign to its opposite as long as we change the sign of the second number. The second number was negative. Now it's just a positive 5.6. Okay? So these are equivalent statements. And now you're just basically saying 7.4 minus 5.6. 0.8, and we get 1.8. Makes sense. We can kind of verify some part of this idea in that there's more positives here than negatives, so we should be left with positives. So that seems like it's a legitimate thing. Okay? That's the answer. Number 60, we've got negative 12 squared, and this is not the same as this. Okay, that is not this, because that looks like negative 12 times negative 12. Which would be positive 144. Okay, but that's not what it says. It doesn't say this. The negative is just sitting out front, not attached to the 12. So a way to think about this problem then is to say what you're really seeing here is negative 1 times 12 squared. Okay? The negative in the front, if it's not trapped to it, is saying take what's resulting here and just make it negative at the end. Okay? And as I say, exponents are lazy. This 2 does not have to act on the negative because there's no parentheses around that whole thing saying the base is negative 12. It doesn't say that, right? It just says a base of 12. So what we're doing is actually this problem right here. And how does that look? Well, that says order of operations then says to keep the negative for now and do just 12 squared, which is 144. Then you do the multiplication by negative 1, and you get negative 144. Okay? Big, important, can't stress it enough idea is that this is not equivalent to this. Okay? This one says negative 12 times negative 12. This one does not. This says negative 1 times 12 squared. Okay? You're going to want to learn that one because it's going to burn you every time it comes up until you learn it. So you might as well learn it sooner rather than later. Okay? Let's move on. Number 61. Number 61 is two negatives multiplied together. Negative times negative is positive, and 5 times 8 is 40. So we get positive 40. Now, just to be clear, if you have a number sitting right out front of a parentheses with no operation in front of it, that means multiply what's inside by what's sitting right here in front. It's like a coefficient of the variable, right? So that one's pretty straightforward. You just need to know that a number sitting right in front of a parentheses with nothing separating it means that it's multiplication. Now, I like this one, 62. And the reason that I like it is because you could draw it out. You could do 4.5 divided by 1.5, okay? Leaving the positive times negative gives you a negative and calling it negative at the end. We'll put that in there to keep track of it, okay? This one, you could do it like this over here, right here. And the rule says you don't want to divide by a decimal number. So what you want to do is you want to move it over as many times as it takes to make it a whole number. Now it's a whole number 15. Okay, but in order to keep the same answer, if you move this one 1 to the right, you got to move this one 1 to the right as well, and now you get 45. So it's the same answer as 45 divided by 15, which, by the way, if you know this, is 3. Okay, so we've got an answer of -3. But I want to show you another way of looking at it. You're essentially doing the same thing with it appearing a slightly different way, which is this. When you have division like this, you can say, I can write it like this. This is also what division looks like. Okay, and then I can multiply it by a creative form of 1, the identity property of multiplication. And what does that give me? Well, that now gives me whole numbers, 45 and 15. And now we could simplify that by doing 45 divided by, 15 equals 3. And remember, this actually should be a negative because there was a negative as a 1.5. And so the answer is negative as well. Sorry, I didn't write that first. Okay, and that's your answer for that. So you could do that multiple ways, but one way to look at it is to just multiply them both by 10 in order to enlarge them but still have the same proportion. We have another slide. Okay, so here we go. And again, if we're adding, we're adding now 2 integers. Okay, we're adding 13 negatives and 6 more negatives. You can think of a negative as a type of thing, and this is how many there are. So if you have 13 of a certain type of thing, and then another 6 more of that same thing, you just add them all together and find out how many of them you have. They still stay negatives. How many are there now? There is 19 of them. That's the answer. This hopefully is a review. Okay. Now, here we have a rule. Generally, this rule is a good rule to follow, which states that if you are subtracting with integers, you keep the first one the same, stays -9, okay? But you turn the second one to its opposite at the very same time that you change the problem from subtraction to addition. Make that plus, and now the -12 is no longer -12, it is +12. Okay? And it's going to result in the same answer. And now you have -9 plus 12. The rule with adding 2 integers of opposite signs is you subtract their absolute values. What is 12 minus 9? Well, 12 minus 9 is 3. And then you say, which was there more of? Was there more negatives, 9 of them? Or was there more positives, 12 of them? There was more positives. So this is going to be a positive answer. Let's box it. Okay. Moving on, we're almost done. We can deal with the signs separately. What's negative times negative? Positive. And that positive times another negative, negative. So we've got a negative result, okay? Every 2 negatives combines together to be a positive, but this one, that last one, doesn't have a match to turn it to positive, so we end up with a negative result. And now we just do 2 times 2 is 4. 4 times 2 is 8. Okay? And in fact, let's do this. Let me just show you what if you did it in steps. What if you just multiplied these 2 together first? -2 times -2 is +4. And then we need to multiply that by the final -2 at the end. So we've got positive times negative is negative. 4 times 2 is 8. We still get that same result, -8. Okay? And finally, and this is a cool one, doing this division, you're basically saying -54 divided by -0.9 or -0.9. Those are the same. What's the rule? The rule says you don't want to divide by a decimal number, so move that decimal over until it's positive. And when we do, we have to move this one past one of the, whatever digits after where the decimal is. The decimal is invisible at the end if you don't see it. So then there's also an invisible 0 after that, and we can move it past that. And then what we get is -9 divided into -540. Okay? And for the ease of simplicity, we know that negative divided by negative is positive, so we're going to get a positive result. So I'm going to just leave those off because it can otherwise mess you up if you're doing this division. So how do we do it? We say 9 goes into 54 6 times. It is 54, so it's a 0. But every number that's there, we got to bring down. So we bring down that. How many times does 9 go into 0? Put it up. So it is positive 60, or just 60. We don't have to put the positive if we don't see it. Okay? Yep. So that is what you do. And you could also look at that one like a fraction, negative 54 over negative 0.9, and say, I need to multiply the top and bottom both by 10 over 10, in order to get two integers. And now the negative divided by the negative is positive, and the 9 goes into 540 60 times. Yep, that's how you do it.